Hello all, welcome to another video of the regression analysis course. In this video, I'm going to talk about the residuals, an estimate of the error term. Let's talk through the multiple linear regression model in a simple way. The model is y is equals to x beta plus epsilon. And here's what that means. Y is the response variable, the outcome we are trying to predict. X is the matrix of predictor variables, the things that influence Y. Beta is the vector of unknown coefficients, and these include the intercept and the slopes. Epsilon is the error term, the part of Y that is not explained by the predictors, by the model. Now, when we have real data, we do know x and y, but we do not know beta. And that's what we need to estimate. There are several methods to obtain that value of beta. One of the methods that we have seen is ordinary least square estimation method, which gives us an estimate of beta. That is x transpose x whole inverse x transpose y. This is our best estimate of the true coefficients. Once we have beta hat, we can plug it back in to get the predicted values of the response variable, which is y hat is equals to x beta hat. And when we plug in the values of beta hat, we get x times x transpose x whole inverse x transpose y. And this can also be written as h times y, where h is equals to x times x transpose x whole inverse x transpose. And we call it the hat matrix because it puts the hat on y. That is, it gives us y hat. And now that we have y hat, we can get an estimate of the error term or residuals, which is the difference between what we observed and what we predicted. That is y minus y hat. Further, y hat is equals to x beta hat. We put the value of beta hat and we have residuals E is equals to y minus x times x transpose x whole inverse x transpose y. And the matrices we have over here using X matrices, we call it hat matrix. And we can further write it as Y minus HY. Now, Y is a response variable. We have it in the first term. We have it in the second term. We can just factor it out and we get I minus H times Y. So we have that the residuals and estimate of error term are a linear transformation of the response vector y using the matrix I minus h, which we also call as the residual maker matrix. Let's look at this estimate of error term, which is equals to I minus h times y. We are dealing with the multiple linear regression model. So we can put y is equals to x beta plus epsilon over here. And we have that an estimate of error term is equals to y minus h times x beta plus epsilon. We can use the distributive property for multiplication and multiply this I minus h with x beta first and then this I minus h with the epsilon. Now in the first term, we again use the distributive property for multiplication and we get I times x beta minus h times x beta, and the second term we write it as it is, that is I minus h times epsilon. Furthermore, if we multiply I with x beta in the very first term, we get x beta, because if we multiply a matrix with the identity matrix, we get the matrix back, and therefore we have the first term as x beta. And for the second term, we put the value of hat matrix back in the equation, and therefore we have x times x transpose x whole inverse x transpose. That is what hat matrix is. And that is multiplied with x beta. And we write the third term as it is, which is I minus h times epsilon. Furthermore, we write the first term as it is because we cannot simplify it any further, and we write it as x beta. Let's look at the second term carefully. We have x transpose times x. We multiply these matrices first. So we group them together and we would have an inverse of a matrix multiplied with that matrix, which gives us the identity matrix. So the second term simplified gives us x times the identity matrix times beta, plus the third term written as it is. Furthermore, we write the first term as it is, and for the second term, we use the fact that any matrix multiplied with the identity matrix gives the matrix back, and we have minus x beta. And we write the third term as it is. Now, the first term and the second term cancels out. We have x beta minus x beta, and we are left with the third term, which is I minus h times epsilon. And thus, we have that an estimate of the error term denoted by E is also a linear transformation of epsilon, and using the same matrix I minus h. And thus, an estimate of error, also known as residual, denoted by E or epsilon hat in multiple linear regression model, has the same linear transformation of y and epsilon. And we call that I minus h as residual maker matrix.